Hi, I'm Melanie. Welcome back to our office at ETIS Foundation in Zurich. In my prior videos, I introduced our Temporal Interference Planning tool, TIP, for the optimization of neurostimulation protocols for non-invasive and targeted deep brain stimulation. Today, I'm thrilled to demonstrate our latest release, TIP version 3.0, that introduces critical functionality for personalized stimulation and exposure assessment. If this is the first time you have heard about TIP, just keep on watching to get a brief introduction. Otherwise, you can skip forward to the timestamp marked below in the description or on the timeline. TIP is a computational modeling tool designed to assist researchers in optimizing electrode placements and currents for their temporal interference stimulation studies. TI is a non-invasive electric stimulation technique that can be used to reach deep brain targets. It works by applying 2 or more high-frequency currents with slightly differing frequencies or phases to produce a low-frequency envelope modulation in the regions where they overlap, to which neurons can respond. TI requires careful optimization of stimulation parameters, electrode locations, and current to ensure selective activation of the brain region of interest and to avoid off-target stimulation. A challenging task considering the large parameter spaces and the complex dielectric environment of the human head. Importantly, TIP is an online accessible tool that can be used without advanced computational modeling expertise. For further details, please refer to our previous videos, which we have linked for you in the description. In the non-personalized version, TIP contains 3 steps. In step 1, the user defines the problem space, for example, the target brain region. In step 2, an optimized stimulation protocol is identified automatically or interactively, and the resulting stimulation conditions are visualized and quantified in terms of key metrics. The final and optional step 3 provides extensive functionality for in-depth exposure analysis. The entire process is presented as step-by-step guided mode application, which greatly simplifies the use of the tool. Now, let's get to the exciting part, the features newly introduced in version 3. With TIP version 3.0, we have migrated our platform to the powerful infrastructure of Amazon Web Services to ensure stability, reliability, and scalability for our growing user community. But here's the exciting part: personalized stimulation modeling. Plugging into scalable computational resources was also a precondition for personalized stimulation modeling to bring temporal interference planning to the next level. While we continue to offer a range of pre-computed, state-of-the-art human and animal models for population variability assessments, with TIP 3.0, users can upload their own anatomical data for personalized TI stimulation assessment, planning, and optimization. This can either be a T1-weighted magnetic resonance scan only, or optionally diffusion tensor imaging data as well, if using anisotropic conductivity in the white matter of the brain is of interest. Now, let's have a closer look at the workflow. First, users need to upload their anatomical data. Uploaders are responsible for anonymizing their data. Our advanced neural network Segmentic then analyzes the data and produces an accurate model representation. This model can be thoroughly inspected using our model viewer which is powered by the Sim4Life computational platform. In the model view, users can then place the 4 fiducial points, which are the basis for the automatic placement of the electrodes. After exporting the points, electrodes are placed as per the standard 1010 electroencephalography system. Optionally, anisotropic conductivity maps are assigned based on the DTI data if such files have been provided in the SIP input directory. On top of that, users can optionally register a highly detailed brain atlas to benefit from a strongly increased number of potential target regions for the stimulation optimization. Back in the model view, the correct electrode placement can be verified. In the next step, low-frequency electromagnetic stimulations for all the individual electrodes are set up and executed. Here, the newly accessible scalable AWS resources offer precious parallelization. The resulting field library forms the basis for the stimulation parameter assessment and optimization in later steps. After the simulations are complete, users can access the data and start the optimization process. There are workflows for 3 TI protocol variants, namely classic 2-channel sinusoidal TI, multi-channel TI, and phase-modulated TI stimulation. Our research at ITIS has shown that personalized model predictions can explain up to 40% of behavioral response differences. Therefore, by empowering users to personalize their stimulation protocols, the predictive power of personalized modeling can be translated into superior stimulation performance. With TIC version 3.0, you have a lot more flexibility, since you are not restricted to the pre-computed models only. Future versions will facilitate the publication and sharing of established plans for specific target regions with selected users or the wider community. Also towards standardizing and harmonizing protocols. You don't have to worry about the costs of using TIP 3.0 that is now running on the commercial AWS infrastructure. It is still free, sponsored by the ITIS Foundation as a service to the research community. Users only need to pay for computational resources from AWS used to perform the 60 complex 3D EM simulations when using the personalized feature. This is about $50 per personalized plan. Thank you so much for watching this video today and for joining us on the journey to push the boundaries of our temporal interference planning tool. As I mentioned before in the video, if you would like more information, then please check out the links that we put in the description box down below. And if you liked today's video and would like to stay connected with us, then please smash that like button and subscribe to our channel. TIP version 3.0. Now it's personal.